Hello everyone, welcome to my channel. Today we are diving into an innovative and efficient technology which is used in modern wastewater treatment, that is the rotatory biological contactor. If we should be curious that how in wastewater treatment we increase the efficiency by combining the engineering and biological things together. Now let's get started. So in this slide, we will take a look at the RBC flow scheme, a step-by-step process used in wastewater treatment using rotatory biological contactor. So let's begin. So when the influent, which is a raw sewage or wastewater entering the treatment plant, first undergoes into the pre-treatment. In pre-treatment, the large solids, grit and debris are removed using screen and grit chamber. This step protects downward equipment. The second step is primary treatment. In the primary treatment, the partially cleaned water enter into the primary treatment unit. Here, the heavier solid settle to the bottom and form sludge, whereas the lighter material float to the top, and these are removed, reducing the solid load. The third step is rotatory biological contactor. After primary treatment, the wastewater flow into the rotating biological contactor. These rotating discs covered with microorganisms that break down organic matter in the wastewater biologically as they rotate through air and water. This is the heart of the biological contactor unit. The fourth step is secondary clarifier. The treated wastewater moves to the secondary clarifier where the biomass or sludge generated by the biological system settle out. The clear water on top forward and the sludge is settled and sent to the solid headley section. In the solid headley section, the solid or the sludge from both primary and secondary treatment is goes for further processing like thickening, digesting or dewatering before disposal or reuse. At the sixth step, which is the disinfection, where the harmful pathogen are removed, typically using chlorine or UV light, and sometimes also other method like reverse osmosis, ion exchange method, etc., to ensure the water is safe for discharge. And the final is effluent. After disinfection, we get the final effluent, which is the treated clean water ready to be safely released into the environment or reused. Now we will see what is a rotatory biological contactor. It is a advanced fixed film biological wastewater treatment device, and it consists of a series of circular discs mounted on a horizontal shaft partially submerged in wastewater. This facilitates the growth of microorganisms on this surface for pollutant removal. The microbial active community is alternatively exposed to the atmosphere in wastewater, which allow both aeration and assimilation of dissolved organic pollutant for their degradation. Now imagine a circular disc like giant CDs mounted horizontally on a rotating shaft, and these discs are partially dipped into a stream of wastewater. Now the magic is this, that the microorganism grow on the surface of the disc and form a thin biological layer which we called as biofilm. As the disc rotate, the biofilm which is present on the disc are alternatively exposed to the air and then the water, and this allow the microorganism to breathe and feed. So in these diagrams, we can see the rotating biological contactor in the side view and the front view. In the side view, we can see that there are several multiple biological contactor discs which are submerged in the raw wastewater, and as they rotate from the shaft, they partially exposed to the air and then the water. From the air, the microorganism present on these discs are exposed to the oxygen for their breathing, and in the wastewater they get the organic matter. In the front view, we can see that these biological discs are not fully covered with water. Instead of this, they are partially or 30 to 40% submerged. And they, if we require the air distributor pipe, so there is aeration also. Now the basic design principle of RBC. This series of circulated lightweight rotating discs are mounted on a shaft through which the wastewater flows. About 40% of each disc is submerged in the wastewater to enable biofilm aeration and nutrient absorption. The discs are commonly made of high density plastic sheet, that is polyethylene, polystyrene and polyvinyl chloride, and are usually rigid corrugated to increase the surface area. The slow rotation, that is 1 to 2 rotation per minute, provide aeration and keeps biofilm active without slugging off prematurely. So these are usually made up of lightweighted plastic, uh, like polyethylene, polystyrene and polyvinyl chloride. And these plastics are roughed or corrugated so that the surface area for the microorganism increases. And the shaft rotate 1 to 2 rotation per minute so that the biofilm present on the rotating disc will not slug off. So this simple yet clever design makes RBC highly energy efficient. So now we will take a closer look at the internal component of the RBC system. At the center of the system is the rotating drum, which hold the media, especially disc, where beneficial microorganisms grow. These microbes break down organic matter in the wastewater. Now we will notice these air cups. These are attached to the media and these help to trap the oxygen and distribute the oxygen as the drum rotate, which is essential for the aerobic microbial activity. Now the blind flage, which is at the end of the drum, ensure a controlled environment. The concrete tank structure with piping support brackets hold necessary connection in the place. Now the bearing on this side allow the shaft to rotate smoothly, which is driven by a motor, whereas the air control valve regulate the supply of air for the diffuser. At the bottom we can see air diffuser and air header, which supply oxygen into the tank, further enhancing the microbial treatment. Everything is securely fixed using the header floor mounting bracket, which ensure the system to runs reliably and efficiently. This setup allow the RBC to operate continuously and treat wastewater biologically in a cost effective and low maintenance way. So now we will see the working of RBC unit. As the wastewater enters the tank or RBC channel, the disc partially submerged rotates slowly, alternatively exposing biofilm to wastewater and the air. The microorganisms attached to the disc surface, that is fixed bag reactor, forming a biological slime layer and consume organic matter as disc rotate. Oxygen for aerobic degradation is absorbed during air exposure and assimilation of organic matter by microorganisms where discs rotate downward. Now the excess biomass is slugged off and removed in a clarifier and sent for sludge treatment process. The continuous process enables stable treatment performance and make it highly efficient. The process of rotatory biological contactor we can see here. The influent or raw sewage first enter the primary settling tank, where the solid settle out. Then the liquid flows into the RBC unit. These are the channels of RBC unit system. Here the microorganism on the disc degrade the organic pollutant as they rotate. Then the treated water goes into the secondary clarifier or secondary settling tank, where the remaining solid and biomass are removed in the form of sludge. As the final effluent flows is clean enough for discharge or further treatment, and the sludge from the primary settling tank and secondary settling tank are goes for sludge disposal after the sludge treatment like dewatering, thickening, and other treatments. And we should be know that the RBC unit is more reliable than the other fixed film processes, because the RBC unit ensure the higher contact time due to rotation, which allow up to 8 to 10 times higher level of treatment than the trickling filter. Also, because of this rotation, both optimum wetting and oxygen supply is ensured. The disc design is made in such a way that large amount of biofilm can attach, which mean that there is a large amount of biological mass present to degrade the pollutant, and this RBC can achieve biological oxygen demand reduction up to 80 to 90%. Now, advantages of RBC over other fixed film reactors. The first is this is energy efficient. RBC require less energy than trickling filter due to low speed motor rotation, that is 1 to 2 rotation per minute, and the improved oxygen transfer. Rotating motion enhance aeration naturally, reduces need for external air system. The low maintenance. The simple mechanical setup allow fewer clogging issue compared to packed back reactors. The higher biomass retention. Due to this, the formed sludge is very less in quantity. The biofilm remains attached to the rotating disc, promoting stable microbial population. This is environment friendly. This ensure the low noise and odor, and suitable for small scale and decentralized wastewater treatment. The compact design ensure the perfect for urban and rural areas. As we know that no system is perfect, so there are few challenges with the or disadvantage with the RBC. The first is mechanical wear and tear. The rotating shaft bearing disc may experience mechanical failure or fatigue over time. Temperature sensitivity. RBC performance decreases significantly in cold weather due to reduced microbial activity. As we know, the growth of microorganism is higher in when they are in the optimum temperature range. So, in cold weather, the growth of microbes generally reduced. Initial installation cost. So, the system is big in size. So, higher capital investment compared to simple systems like trickling filters. The odor issue. Exposed rotating media can emit unpleasant odor, especially in the warm climate or poorly ventilated area. And that's a wrap on the rotatory biological contactor, a powerful example of how biological science and mechanical engineering come together to protect our environment. So, if you found this helpful, please like, share, and subscribe. Thank you for watching.